On a previous episode, we made the board for the teensy that sits in the middle of the CDJ. On this episode, we're going to be concentrating on the cue and play board, how the Pioneer read it, and how we are going to read it. The first problem that we can see is the cracks on the plastics for the buttons. Now I've repaired that with some plastic glue. It won't last forever, but it's good enough for what I want it for. Now we're going to look at the board, the KSWB board, if you look in the service manual. And on this board, the Q button has a bad track, so we need to repair that. We can see somebody else has repaired this board and they've lifted the pad for the switch. We're going to take the button off and put a new one in, bend the leg over, and then we can solder onto that leg. Just heat up the pad, a little bit of solder, and we can just pull it out from the other side. Take a new button, push it in. Again, just a little bit of heat on that pad, and we can just push the button straight through. Now push the button from the bottom and push it up while you're applying heat so that the button is flush with the other side of the PCB. Cut the leg off that we soldered, but leave the other one. We're going to bend that leg over and solder it to one of the tracks on the board. First, we need to scrape the protective layer off the track so the solder will stick to it. Be careful on this. You don't want to take the whole thing off. If there's no copper, we can't solder onto it. Now apply some solder to the copper that we have revealed. Bend the leg over, trim it down. Push it as flat as you can get it, and then some more solder so that it sticks to the track that we have pre-tinned. I'm going to use the part of the leg that we cut off to fix the other side of the track. So from the resistor to the switch leg. That's completed that circuit. It's not very tidy, but again, this is just for me. It doesn't really matter. Before we get into converting this, I want to show you how the CDJ reads the buttons, because they work in two different ways. We have direct buttons like Q and play, and then we have what I call button arrays. In this case, track and search buttons all read off the same connection, which on the PCB is labeled as key 0 underscore B on pin number 4. Pin 1 is ground, which is common for all of the buttons. Pin 2 is play, and pin 3 is Q. Pin 4 is track and search. All 4 buttons work off that one connection. Each button has its own resistor, so when you press the button, the resistor value changes, and the Pioneer see that and interpret it. If we were to use that as it stands, we would have to have an analog input for those 4 buttons, and then the software would have to see the different values when those buttons are pressed and figure out which button you are pressing at whatever time. This adds a lot more programming, and at the same time would add a lot of latency. This is how I did it on the CDJ 800, but now we've got enough digital inputs, we can change this so that we can read each button directly. So here's my example. Black is ground, white is play, grey is Q, and the purple is track, search and search. So now we have play wired up, and when we press it, we get a change in resistance. Change it to continuity, and that shows that we have pressed the button. So now let's put that onto the Q button. Play does nothing. So now if we change it to the wire on pin 4, which is the analog section, when we press track search, we get different resistance values depending on which button we have pressed. If we press combinations, again we get a different resistance value. Now we're going to convert the board to direct digital inputs by removing the resistors that give them their different values. We can see that on the diagram. I've highlighted them in red. So we have 2301, 2302 and 2303. So I just did this with my soldering iron. You just need to get both ends hot enough and then just flick the surface mount resistor off. Please excuse my Venetian blind blowing as I have my windows open. Quite possibly the most annoying sound ever. So now we're on the second resistor. Doesn't matter if we do any damage. We're going to cut the tracks next. Okay, that's the 3 off. So now I'm just going to use some solder wick. Just clean that up. Make sure that we don't have any shorts affecting our button switches. Now we're going to cut the tracks that join the 4 buttons together. We want them to be separate buttons so that when you press one button it doesn't affect any of the other 4. I actually made a mistake here and I cut through the ground LED track. Now we're just going to make sure that that just doesn't work as it did before. Now we're going to solder wires directly to each of those 4 buttons. So we solder onto the positive leg of each one. It's quite obvious which is which because the ground is all one big ground plane. So just put a little bit of solder on each leg first, tin the wires, and then a quick dab, and they will stay in place. There we go, it's all 4 wires connected to the 4 switches. Back to the multimeter, and now we're going to check each button individually for continuity, and also to make sure that other buttons don't affect them. We want each button to work on its own. Last one. So that's all 6 of those buttons now operating individually. These CDJ 1000s use 12 volt for the LEDs, so we can't power this from USB. But what we can do, if your faulty CDJ has a working power supply, is we can take 12 volt and 5 volt from the CDJ. If we take it off this board that we're looking at, we can go through the fuses to protect our equipment. So we just need to connect onto that wire however you want to do it, and then we can utilize that. So I'm just going to show you on my example using a breadboard, and we've got 12 volts on the right and we have 5 volt on the left. So on our breadboard we have 12 volt on the right, 5 volt on the left. The red peg is 12 volt and the yellow peg is 5 volt. We have a common ground between the two of them. So as we see, we go onto the yellow, 5 volt, and the red was 12 volt. These are the two transistors that switch on the LEDs. We need to connect the ground from the 12 volt to G LED and the positive from the 12 volt to V LED. This is common across the whole of the CDJ. So we may need to apply this to all of the separate PCBs. So now we can see pins 5 and 6 are to turn on the Q and the play LEDs. And to do this, we need to apply 5 volt to those pins. Now if we're using a teensy, we only get 3.3 volt out. So the LEDs might not be as bright as they should be, but they'll still be bright enough. So I'm just checking here which pins go to which pads. And now we can tin the pads and connect 2 wires to them. So basically 12 volt goes to VLED, and then our digital output from the teensy goes to those 2 pads. On the main boards we have solder points next to the transistors that we need to turn on. So it's basically the same thing, just the boards are laid out differently. So first we're going to connect the V LED and G LED to the 12 volt ground and the 12 volt positive lines, which is the black and the red. And then to turn on an LED, we apply 5 volt to the transistor. So that would just be the same as our teensy setting a digital pin high. So thank you for watching this episode on how the Pioneer CDJ buttons work. Some of them are digital, some of them are analog. We want them all to be digital. And we've also seen how we can turn the LEDs on. 12 volt goes to the LED circuit, and then we send 5 volt to the transistors, which turn each individual LED on and off. Next episode, we're going to look at how the pitch works.